In only a few months, Ukraine has destroyed or captured more than 187 Russian T-90 and T-90M tanks, mostly through precise drone strikes, ATGMs, and artillery fire. At the same time, the first American Abrams deployed to Ukraine, despite taking losses in a drone-heavy environment, still showed a higher crew survival rate thanks to Western safety design. These numbers reveal a surprising reality. When the tanks that Russia calls its most advanced meet the battlefield in Ukraine, the winner is not decided by armor thickness or gun caliber. It is decided by adaptation, speed, and Ukraine's ability to use new technology faster than its opponent. The sight of a T-90M and an M1A1 Abrams moving through a ruined town is no longer a simple clash of steel. It is a reminder that Ukraine is shaping the battlefield with creative tactics and smart positioning, not just heavy vehicles. But one question remains. If multi-million-dollar tanks can be disabled so easily, what does this mean for Russia's armored forces and for the future of tank warfare? This shift affects not only Ukraine and Russia, but also NATO, Europe, and America's long-term military planning. And that brings us to the key question viewers want answered. When the T-90M and Abrams meet in Ukraine, which side truly holds the advantage? The answer lies in one unexpected truth. The tank duel the world expected never happened the way anyone imagined. What changed the game? Let's break it down. Russian armored columns entered Ukraine in February 2022 and created a battlefield shaped by speed, heavy fire, and constant pressure from several directions. Russian units moved forward with infantry, artillery crews, airborne assault forces, and attack helicopters, and the first waves tried to break Ukrainian lines before defenders could reinforce key towns. More than 2,000 Russian tanks crossed the border during this period, and among them were T-90A and T-90M Proryev vehicles, which were sent toward major axes of advance in the north, east, and south. These tanks moved behind screening units that cleared mines and obstacles on the main roads. The armored groups reached several junctions before Ukrainian units could fully prepare trenches or anti-tank lines, and this created moments where Russian tank crews fired at targets that were still repositioning. Ukrainian forces used T-64BV, T-72A, and T-80BV tanks during this stage, and these vehicles were deployed in small groups across long stretches of open terrain. The first contact between Russian armor and Ukrainian defenders happened along highways leading into the outskirts of larger cities, and Russian crews used their thermal sights to scan broken tree lines that hid Ukrainian units. This allowed T-90M tanks to hit Ukrainian vehicles before they moved into deeper cover, and several defensive points were pushed back because the first rounds landed faster than expected. Russian armored formations then advanced across farmland, where open fields gave them wide arcs of fire, and Ukrainian crews had to shift from one line of cover to another to avoid incoming shells. The T-90M gun crews used long-distance shots to hit Ukrainian tanks that were trying to relocate, and the early engagements forced several Ukrainian vehicles to retreat toward secondary lines. The explosive armor on the T-90M reduced the impact of older Ukrainian rounds, and Russian tanks continued to fire as they moved along the flanks of main roads. As Russian pressure increased, Ukrainian commanders ordered their tanks to reposition inside narrow streets and small industrial areas to reduce the visibility of their movements. Russian reconnaissance units watched these zones with drones and marked Ukrainian firing points for the advancing tanks. This coordination allowed Russian armor to strike positions on the edges of towns where Ukrainian crews tried to form temporary defensive pockets. The T-90M units pushed deeper into contested areas during the first weeks and used their sensors to identify heat signatures inside damaged buildings that Ukrainian troops used for protection. These signatures helped Russian gunners deliver accurate shots into windows, alleys, and storage yards where Ukrainian armor had taken cover. Several Ukrainian tank crews had to abandon positions once Russian artillery joined the attack, because shells fell on routes used by Ukrainian vehicles to escape. Russian armored groups then shifted toward the next set of defensive lines and used side roads to approach Ukrainian tanks from unexpected angles. This movement placed pressure on Ukrainian units that were already stretched thin across several fronts, and Ukrainian crews had to move through debris-filled streets that slowed their reaction time. Russian tanks continued pressing forward while supported by infantry teams that cleared nearby structures. Ukrainian defenders tried to slow the advance by forming short-lived blocking positions near bridges and fuel depots, but Russian fire reached these areas before the positions could be reinforced. By the end of the first major phase, Russian T-90M units had pushed into multiple contested regions and forced Ukrainian tanks such as the T-64BV, T-72A, and T-80BV to fall back into tighter defensive belts around larger urban areas. These movements set the stage for the next phase of the war, when Ukraine began searching for new ways to counter Russian armor without relying on head-to-head tank engagements. Ukraine changed the course of armored warfare when it stopped chasing direct tank duels and started targeting Russian vehicles from angles where armor means very little. The new Ukrainian approach focused on hitting these vehicles before they could fire, and this approach pushed tank crews into a fight that no amount of steel could solve. The core of this strategy is distance and vision, and Ukrainian soldiers rely on Javelin and Stugna P teams that watch every road and tree line for movement. These missiles strike from above, and they arrive with enough force to overwhelm even modern armor blocks. Ukrainian operators use speed and calm timing to hit the tanks during moments when they slow down or attempt to adjust formation. When a Russian crew tries to find cover or angle the turret to shield the front plate, the missile closes the gap from a high arc and defeats that shield. The result is damage inside the fighting compartment, and the vehicle often stops long before it reaches Ukrainian positions. The rise of FPV drones in 2023 added a new layer to this battlefield, and these small aircraft turned every weakness on a tank into a clear entry point. Ukrainian operators guide them low across the ground or through broken rooftops until they reach the turret ring or the top plate, and these locations cannot absorb the shaped charge. The drone usually strikes at the exact moment the crew tries to rotate the turret or change direction, and this delay gives the operator enough time to place the drone with accuracy. The hit forces pressure into the crew space, and the vehicle loses both vision and coordination. Reconnaissance drones complete this system by watching the area from above, and they mark each enemy tank with simple heat spots on a tablet screen. Artillery teams use these marks to target the vehicles before they even enter firing range. One battery can stop a column by hitting the lead tank and the last tank in the line, and when this happens, the remaining vehicles become stuck between broken trees and burning metal. Ukrainian anti-armor teams then move through trenches and ruined buildings to finish any tank that survives the first barrage. The T-90 and T-90M share one critical flaw that makes these strikes even more effective, and that flaw sits under the crew in a circular rack that holds the ammunition. When a missile or FPV penetrates the armor near this rack, the explosion pushes upward into a confined space. The force has no path to escape, and the pressure launches the turret or destroys the crew instantly. This pattern appears in many battlefield clips where a drone enters a small gap near the turret ring, triggers the ammunition, and turns the vehicle into a fireball. Ukrainian units understand this design weakness, and they choose angles that force the blast into the compartment instead of against the exterior plates. These events raise one question that many viewers continue to debate. Do Russian tanks fail because of outdated design choices? Or do they collapse because Ukraine created a combat system that destroys any tank that enters its range? The arrival of Abrams and Leopard, two tanks in Ukraine, created a wave of hope because many believed these vehicles would bring a clear advantage on the battlefield. Yet the first months of action showed a far more complicated picture. Ukrainian crews learned that these platforms offered strong protection and accurate firepower, but they also discovered that modern combat demands more than armor and superior optics. The front line turned into a testing ground where Western engineering met a battlefield shaped by drones, artillery, and constant surveillance from Russian units. The strength of the Abrams became clear the moment crews survived attacks that would have destroyed older tanks, and the design of the ammunition compartment played a major role in this outcome. The use of blowout panels allowed explosive force to escape upward when the vehicle took a hit near the ammunition storage, and this feature protected Ukrainian soldiers who would have faced fatal injuries inside other platforms. The thick layers of composite armor reduced penetration from many directions, and the advanced thermal sight helped crews see movement before Russian units noticed the threat. Ukrainian tank operators used these advantages to support infantry during difficult pushes, and the vehicles often opened fire with confidence in areas where visibility and distance control decided the timing of each shot. The challenges of the Abrams appeared in the next stage of operations when frontline conditions forced Ukraine to move supplies through narrow roads and open fields. The turbine engine burned large amounts of JP-8, and this fuel demand created convoys that attracted Russian drones hunting for high-value targets. Ukrainian units tried to hide these convoys behind buildings and tree lines, yet the constant presence of Russian reconnaissance drones made secrecy almost impossible. When FPV strikes hit supply trucks, entire tank units had to reduce movement because their engines could not run without steady resupply, and this limited the number of operations where Abrams could move freely. The threat from top attack drones created a second layer of danger because they targeted the thinner armor on the upper surface of the vehicle. Ukrainian crews placed camouflage nets, thermal covers, and improvised shields to reduce the chance of detection, yet drone operators adjusted their angle of attack until they found gaps near the rear deck or turret roof. These strikes did not always destroy the Abrams, but they caused enough damage to force repairs or relocation, and each repair drained time and manpower from crews already working under pressure in a contested zone. Maintenance demands posed another challenge because the Abrams contains complex sensors, fire control computers, and engine parts that require trained personnel. Ukraine used teams that learned quickly, yet the workload remained heavy since battlefield conditions introduced dust, mud, and temperature swings that created additional stress on the vehicle. Crews spent long hours checking systems in temporary shelters, and this effort kept the tanks running during intense battles, although the pace of combat continued to stretch available expertise. These realities pushed Ukraine to pull Abrams from several offensive routes, and this decision sparked debate about the best way to use Western armor in a drone-based battlefield. The fights where T-90M and Abrams appear on the same front line show that each clash is shaped by how well both sides connect their drones, scouts, and vehicles. This becomes clear in the engagements where Ukrainian forces link tank crews with drones, scouts, and infantry teams at the moment the first Russian vehicle exposes itself. The Pokrovsk battle began when a Leopard 2A6 detected heat movement beyond a broken rail line, while an Abrams nearby received the same signal from the drone team overhead. The Leopard held its turret under a damaged barn roof, while the drone circled the southern block of the town and streamed coordinates of a T-90M advancing behind a line of shattered houses. The Ukrainian crews waited until the Russian tank crossed a narrow lane where its turret had to rotate, and the Abrams fired the opening shot from a position hidden by collapsed walls. The round hit the upper turret and forced the T-90M to stop, and a second shot from the Leopard struck the rear quarter as the Russian driver tried to reverse toward a ditch. The Russian crew stayed inside for several seconds while smoke covered the street, and a Ukrainian drone dropped from altitude and flew through the open hatch after spotting a flash from the interior. The explosion turned the turret into a block of fire and turned the once proud jewel of Russian military into a burnt mess. The second Russian tank in the same sector attempted to swing north behind a concrete silo, yet the drone team tracked its path across a strip of mud that carried visible engine heat. The Abrams moved between two farm buildings to block the Russian exit, and the Leopard shifted left to trap the vehicle near a damaged fence line. When the T-90M turned sharply to regain speed, the Leopard fired a sabot that clipped the turret ring and forced the crew to abandon control. The drone team then sent a low-flying FPV that slid under the storage shed roof and struck the top plate of the immobilized tank. The blast caused flames to shoot from the barrel, and the area was cleared within minutes. One battle fight in 2024 shows the same kill chain because the Bradley moved across a wet field and held fire until the T-90M exposed its sensors at the edge of a trench. The Bradley gunner aimed at the optical unit mounted above the main gun, and the stream of 25mm rounds cracked the housing that controls target tracking. The Russian turret stalled as the driver attempted to pull back into the ditch, but the crew abandoned the tank once they lost visual control. A Ukrainian drone watching from above dived toward the turret while the crew ran across the field, and the FPV detonated inside the upper compartment where the fuel heat signature still lingered. The tank burned in place while the Bradley reversed into a grove of trees to avoid return fire from another Russian vehicle entering the area. Both encounters show that the decisive moment arrives when an FPV drone moves in after the tank loses mobility or sight. These drones fly close to debris and rooftops until they reach the gaps that armor cannot cover, and they end the fight long before a second Russian crew can react to the first strike. In a real head-to-head moment shaped by drones and shared targeting, which crew would act first and which machine would survive the opening hit? The biggest lesson from recent battles is that modern armored warfare depends on teamwork between tanks, drones, and electronic warfare units. Armor alone no longer protects a crew when threats arrive from multiple directions, and every army is adjusting its plans to match this reality. Ukraine's frontline experience shows that tanks survive longer when they receive information from the sky before they move into open terrain. The rise of cheap FPV drones proves how fast the battlefield has changed. These drones cost only a few $100s, yet they can damage multi-million-dollar vehicles when they strike weak points on the turret roof or the engine cover. Ukrainian operators guide FPVs through narrow gaps, and Russian crews often react too slowly once the drone begins its final approach. Russian units face the same pressure when Ukrainian FPVs search for targets across fields, roads, and ruined farms. This new threat forces tank commanders to move more carefully and avoid traveling in predictable lines. NATO planners now study this pattern because the cost gap between a drone and a tank keeps growing, and the side that adapts faster gains the advantage. The development of next-generation tanks reflects this shift. The Abrams X aims to protect crews with thicker turret roofs and advanced sensors. The T-14 Armata follows the same direction with a remote turret and stronger defensive systems. Both designs try to merge several sensors into one picture that helps crews find threats before they appear on traditional optics. They also plan to use small support drones that fly ahead of the main vehicle. These drones search for FPV teams hiding behind damaged walls or inside tree lines, and they give the crew a few extra seconds to react. New active protection systems try to destroy incoming munitions before impact, and this feature shows how fast engineers are changing their approach to armored vehicles. The political situation around this conflict makes these lessons even more important. NATO views Ukraine as a place to observe how modern warfare works under constant drone pressure. Their findings shape military planning in Europe and influence future budgets. Russia tries to answer by increasing production of the T-90M. Factories push to replace losses and keep frontline units supplied with modern tanks. Engineers add protective cages and updated sensors, but the rapid development of FPVs makes it difficult to stay ahead. The United States now faces a strategic decision. Some experts want to send more Abrams tanks because they still provide strong firepower and high crew protection. Others believe that drones and electronic warfare units offer better value in a conflict dominated by surveillance and top attack strikes. Ukraine continues to request both types of support, yet commanders often rely on UAVs to decide when tanks should move. This balance shows that heavy vehicles remain useful, but they can only operate safely when drones clear the path first. The future depends on whether tanks can evolve fast enough to survive in an environment filled with sensors and precision weapons. Do you think heavy armor will adapt to this new world? Or will drones slowly take its place on the battlefield? The closing view of this war delivers a shock, because two of the world's most advanced tanks have struggled against weapons that cost a fraction of their price. Russia lost many T-90M units, even though the tank was promoted as a core symbol of its modern army, and Ukraine had to pull several Abrams away from the front after repeated top attacks from small drones. The pattern shows that the real danger no longer comes from tank-against-tank duels. The main threat arrives from above, where FPV aircraft, guided munitions, and fast targeting teams turn every armored push into a risky move. The T-90M carries strong guns and advanced armor, yet the ammunition stored inside the hull remains a point that cannot survive a direct hit. The Abrams protects its crew better than most vehicles ever built, yet the heavy turbine and exposed upper surfaces make it vulnerable in a sky filled with drones. These lessons suggest that future tanks must rely on sensor networks, active protection, and drone cooperation if they want to survive in battlefields shaped by rapid strikes and constant surveillance. The next generation may include the American Abrams X, or the Russian T-14 Armada, and both promise stronger defenses. The question is whether they can truly change the balance or whether drones will continue to set the rules of modern combat. Share your thoughts in the comments, and remember to like, share, and subscribe to Military Force for more updates.